Get ready to dive into the amazing world of eBPF. It is now time to make our first probe. Hey there Pixelers, it's Michael Haddon. eBPF is a game-changing technology that lets you supercharge the Linux kernel and peek into its inner workings like never before. We'll be using the power of C to craft our eBPF masterpiece, and trusty Python to manage and decode its events. Sure, Rust enthusiasts might argue that you can do this all with Rust too, but why complicate things? Let's keep it simple and fun, and trust me, you'll be blown away by what we can achieve together. Are you ready? Okay, let's get started. If you haven't done so yet, I highly recommend catching up on my previous eBPF video to get all the juicy context and purpose behind this incredible technology. Trust me, you won't want to miss it. Now, let's gear up and prep our workspace for some eBPF magic. We'll be installing the BPF Compiler Collection Toolkit, or BCC, to give us all the tools we need for eBPF wizardry. 1. Install BCC and its essential dependencies. This will be slightly different depending on your distribution. 2. Create a slick Python virtual environment to keep everything neat and tidy. Are you ready to unleash the full potential of eBPF? Alright, let's do this. We'll be tapping into the pulse of the sysclone function, which springs into action when a brand new process is born. This may sound confusing. Let's say you are running a program or command on your computer, like opening a web browser or running a script. When this happens, the operating system needs to create a new process to manage the execution of that program or command. The sysclone function plays a crucial role in this process creation. We can create a hook which taps into and lets us monitor that kernel command. Let me show you. Let's kick things off by crafting our eBPF program in C. Let's create a file called ebpfprobe.c. We prefix our function with kprobe__, instructing the BCC library that we are ready to attach it to a kprobe. By specifically calling the function sys_clone, we are watching the kernel sys_clone event. The CTX variable is a pointer to the current event context. We'll light up the kernel trace buffer with a simple message, using this snazzy print statement, perfect for debugging and testing our creation. Gracefully exiting with a 0, we give a big thumbs up, signaling that we're stepping out of this function on a high note. Next, let's whip up our Python script to join forces with the eBPF program. Let's call this eBPFrunner.py. We import the BCC library fresh from our operating system's package manager. Loading the C code from its file, we put pedal to the metal, compiling it with BPF and launching it into the kernel. The trace print statement keeps us in the loop, automatically printing out any changes in the trace buffer. Ready for liftoff? Remember, run this code with privileged access. And there you have it, our first eBPF program. It is simple, fast, and, well, a little bit useless for now, but wait until we unleash its full power. Now, let's turn it up a notch and make it even more powerful and informative. No more plain hello world messages, we want real actionable data. Our eBPF program runs in a super secure sandbox environment, right alongside the mighty kernel. Meanwhile, our Python application is chilling in Userspace, a fancy term for where our everyday processes hang out. Now, even though our eBPF program has some limitations, for security and stability reasons, that doesn't mean it can't flex its muscles. In fact, it's able to send data over to our Userspace application, which can then report, record, and perform all sorts of amazing tricks with the received data. Let's do this. We can enhance our C code by adding extra header files to unlock access to vital data structures and functions. Next, we'll define a data_t structure to store all the essential process information like PID, process ID, PPID, parent process ID, and the process name itself. Now, it's time to unleash the power of BPF perf output. This nifty definition allows us to send data from our eBPF program right back to our Python application running in Userspace. We'll use the events reference later to transmit our data. With everything set, we can gather our current task using the BPF getCurrentTask function, and send our data back to our Python application with events.perf submit. But hold on, there's more. our Python code needs a little makeover to properly report the collected information. Let's say goodbye to the trace_print method since we're done with printing log lines straight from our eBPF buffer. Instead, we'll listen to the perf output from the eBPF application and pass the results to our brand new logging method. For now, let's keep things simple. Our process_function takes 3 parameters: the CPU index where the event was generated, the event data itself, and the size of the event data. Finally, we continuously poll the perf buffer for new events. If we run this, we can see our output packed with exciting process data. Let's take our eBPF probe to new heights by expanding its reach to even more events. First, we'll whip up a shiny new data structure to hold the payload for our latest event, monitoring file open events. Then, we'll create a brand new perf output to send this data back to our Python application. Time to do a bit of housekeeping. Let's tweak our sys_clone function to point to its dedicated perf output. And now for the grand finale, we'll craft an awesome new function called kprobe do_sys_open_at_2. This beauty will hold the do_sys_open_at_2 event like a charm, collecting valuable file opening information. I think you guys know what's next. A few swift changes to our Python code and we'll be reporting both events in no time. Just create a new event handler and point to that fresh event information, and voila, we are now in full control of an eBPF probe that's more powerful and informative than before. I think it's time to take a break and celebrate our eBPF mastery. We can now extrapolate out how we can integrate such functionality into our organization. Let's integrate it with Prometheus, the go-to open source monitoring and alerting toolkit that'll make your metrics shine. First things first, let's snatch up the Python's Prometheus client with a quick pip install. With that in place, let's get our hands on it by importing the package into our Python application. Now, it's time to create a couple of Prometheus metrics, sys_clone equals total and sys_open_at equals total. Fire up a HTTP server to host our Prometheus metrics and let it work its magic in the background. Next up, let's expand our process_clone_event and process_open_event functions by incrementing our new Prometheus metrics. Once it is running, all we have to do is go to our new server and we will see our metrics. Once it has started scraping, Prometheus will let us automate alerts and query this new valuable data. Why not step it up a notch and integrate with tools like Grafana to transform your data into stunning graphs? Unleash the potential of your implementation by tracking even more metrics per syscall. Add labels to filter metrics such as by file path, and get ready to be blown away by the insights you will uncover. Some quick tidbits to leave you guys with. 1. Streamline your eBPF programs. Keep your code lean, mean, and efficient. Offload as much logic as you can to your Userspace application. 2. Test across kernel versions. Don't let kernel updates catch you off guard. Ensure your eBPF programs are rock solid by testing them against different kernel versions. 3. Explore the world of syscalls. There is a treasure trove of syscalls waiting to be discovered. Dive deep into their purpose and unlock endless possibilities for your eBPF application. 4. Leverage the power of strace. This fantastic tool lets you peek under the hood and see what syscalls your application is using. It's like having X-ray vision for your applications. Now, it is time for you to go forth and harness the power of eBPF in your own projects. Be sure to check out for future videos where I will expand upon this further. Thanks for checking out this video. As always, I hope you guys have a lovely day. Cheers.